Okay, is it live? So hello everyone. Am I audible? Hello. Okay. So let me introduce a little bit about IICPC Summer Camp. Uh, like uh, okay. So basically, me with my colleagues like Aitya Mitra, Gauris Valigan, like a lot of big team is there. Okay. So our initiative is currently we are united by elites, competitive programmers and developers across 40 plus IITs, triple IITs, BITS, numerous universities and all. Right now we are around 10K plus registrations and all. Okay. So our motive was to cultivate passion and interest in competitive programming while offering assistance to the beginners. So this is our inaugural public initiative towards achieving that goal actually. And I hope you all will like the first session we are starting with our honorable Vivek Gupta sir. So let's talk a little bit about Algozenith. Okay. So Algozenith is the premium platform for internship placement and all. Okay, placement preparation. I'm pretty sure a lot of guys are here who would be having internship season next month and all. So Algozenith would be pretty useful for them. It has also like comprehensive programs like DSA development, like competitive programming, projects, resume building, and referrals and all. Even students from Tier 3, there is some unique thing like students from Tier 3 college and non-circuital departments and IITs also have like secured positions at top tier companies like Google and all. So we have right now Vivek Gupta sir. He will be taking the GP session. We have another sponsor, GXPPL. GXPPL is that empower the next generation in crypto and Web3. Okay. It was founded by Prasna Sanjay, that is founder of Rippling. He was also like rank one in India in top coder, ACM, ICPC, Google Code Jam at the age of 18, right? So GXPPL has had like several ICPC world finalists, and you can join 0xPPL if you are excited about career opportunities in startups and all. So you can reach out at this mail ID, prasanna@0xppl.com to connect. Rest, we'll discuss more with the sir and all. He will be taking the session. So he will be motivating you all for first few minutes and all to go through competitive programming. And so, sir.
Yep. Hi everyone. First of all, am I clearly audible to all of you? Just just drop in a quick +1 in the chat, guys, if you are able to hear me. Let's see how many are there. Okay. Chalo guys, I think things are working fine then. Let's get started. So I think a lot of you guys, like this is the first session and like this is going to be on dynamic programming and we're going to talk about a little like non-beginner stuff maybe. Like we'll start with like dynamic programming, it has recursion and stuff. But I think like this is the first session and I think a lot of these fundamental things that we will talk about is going to be relevant even for everybody else. So I think I don't need to give you guys any motivation on why you should do competitive programming and all. People who have joined it and are kind of going through this camp most probably are already like motivated enough, and we are gonna like kind of cover a lot of different things, and there is like a lot of speakers who are gonna come and like give you guys ideas on different topics. We'll start with dynamic programming today. A little bit about me, like for those who don't know. So I like graduated in 2021, worked at Google for some time, then I worked at this company 0xPPL, which is also a sponsor for this camp. So have worked there as well, and then I'm now working full time on Algozenith. Right. So this has been a really great journey. Have done a lot of competitive programming in my college. Have done it for around 3.5 years. Qualified for this Olympiads of programming called ICPC World Finals. So that is something I feel is a big achievement in the field of competitive programming. And then have been teaching for a long time too. Have been teaching for almost 4.5 years now. So I started teaching in my college to the school students in US for this competition called USACO, right from my third year end. So that has been a really fulfilling journey too. Okay, so this should be a good quick brief. I don't know how many of you know like YouTube pe kabhi dekha hai and stuff. I've seen some video on YouTube around certain content. Some people would have seen for sure, right? For those who are learning competitive programming, some content, but generally I create content around intermediate and advanced topics, not so beginner friendly, right? Great. Penguin fan club. Okay, I have seen you. Good. Okay, DP workshop. Okay, so we are all the way back to DP again today, right? So we'll start with DP, and I think there is so many things to talk about today, but I think it's great to see so many people starting off competitive programming and coming into this field. Initiatives like this make sure that students in India, even abroad, are kind of getting into this problem solving field, because with AI and things coming in, maybe a lot of repetitive tasks are going to be like removed off, but problem solving is something that I feel will always be like the core skill that differentiates human. So it's great that you are kind of putting in efforts to be great at this, right? With that, I mean, I'll give it back. If you have anything else to cover, then we can do that, or we can also move to the session, whatever you guys have planned. Yeah, so maybe you can like then I can share my screen then, and you guys can like drop the like slides presentation, maybe what you are doing, and then I think that should be the way to go. I'll select my entire screen and see if I can do that. Like, see if you guys can pin this to the screen. I think that would be the way to set it up. Right? Great. So we're talking about dynamic programming. I think you guys have a lot of questions. We'll talk about certain small things. Vivek, how to reach expert in 6 months, how to reach different levels, how to grow and stuff. These all things we will talk about at the end a little bit, right? And I know that there are so many questions that you might have, Vivek, how the things will run, how will be there. Uh, will you be able to see this later? Maybe not. Okay, this is something that these IICPC guys will decide. Okay. But I think what is important is you attend these classes, learn to think from these and actually solve, because at the end of the day it will be your grind that will be super important for this, right? Okay, let's get started with dynamic programming. Okay, how many uh, of you know what dynamic programming is? Solving. Is it for ICPC? Yes, it's ICPC. Yeah, I think even if you're a beginner, if you know what recursion is, you will be able to understand today's lecture. So there is no dependency altogether. Okay, don't worry about it. So how many of you have learned something about dynamic programming? Quick +1 if you have done something till now on DP. So we will call, if I say DP as the next word from anywhere, understand that it means dynamic programming and not some gun's name or things like that. Okay. Last time I was in a new session, somebody said DP gun ka naam bata rahe ho kya? No, it's dynamic programming, the topic, right? Okay. So we'll start from fairly basics, and I think you will be able to appreciate what dynamic programming offers you, because it's so beautiful that like oftentimes people make it complicated, but when you understand it to its core, it's super simple thing, right? It's just glorified recursion with basic caching. Okay, what are these terms, Vivek? Or caching or memoization, what you would say as another word for it, right? Yeah, we'll build intuition from very basics. Sabko loop chalana aata hai, everybody knows looping, everybody knows function calling. If you can do that, we will be able to understand everything in today's session. Okay, great. So let's start with the like content a little bit, and I'll also kind of show you guys certain visualizations that will help you to build intuition around it. Okay, also, just I think in case you guys missed on this, there will be a small QR code which will be like an attendance for people who want to get certificate and completion of the camp. So not attending it essentially means you lose that. Okay, so attend karna hai, seekhna hai, and then complete it properly. Okay, complete the camp properly. How long will this session be? Let's see. Jitna der, the longer you want it to run, as long as you can take it, that's the thing. Okay, let's get started, guys. So Everybody knows this function, right? I think I don't need to explain this function for many of you guys. How many of you know this? Plus minus 1 will tell me at what level should I start. How many of you can understand this piece of code? Quick plus 1 in the chat, because this will tell me at what level I'm teaching today. Everybody can understand this piece of code. I think any basic programming course would, like, if you have done, you'd be able to read this code. Very, very simple. Factorial. Given n, you have to find out n factorial. N into factorial of n minus 1 is nothing but n into n minus 1 factorial. That is what will lead to finding out n factorial, right? Because that's the definition, because this will again expand to n minus 2, n minus 3 factorial, and so on, right? So these kind of functions might be something you have seen before, but I don't know how good are you with recursion, but fundamentally the idea of recursion is nothing but to understand what dependencies are you trying to solve. Okay, for an example, in this case, if you call factorial of 5, right, factorial of 5 depends on factorial of 4, right? Factorial of 4 depends on factorial of 3. Factorial of 3 depends on 2, 2 depends on 1. 1 is a base case, because if n is equal to 1, you know you're returning 1. So this is a base case. And then things return in recursion, right? And I'm not here to teach recursion today to you all, okay? So don't expect me to teach recursion today. I'll expect that you know how recursion works, basic, okay? So if you give n equal to 1, that you know as a value, so this will call this, this will call this, this will call this, this will call this, and this, then the stack will return, okay? So this is essentially what recursion looks like. But then what I've felt is recursion in general is hard for students. How many of you think recursion is hard? Quick plus 1 in the chat. Ki Vivek, recursion samajh mein nahi aata. Sometimes I'm not able to solve questions of recursion and all. Okay, some. Okay, I can get the picture. Depends on rating. Okay, rating of the question maybe, right? How hard the question is. Okay, somewhere in middle. Okay, so recursion isn't that hard, but I know what you're saying. Why is it hard? Because generally what happens is no real life process in our life is actually recursive. Like if I tell you, give me one example of something that is iterative, you will be able to most probably give it. But if I ask you, give me a real world example of something is in recursion, can you give me one? Give me one example of real world recursion. है क्या कोई example? Tree is not recursion. Break up and patch up. So that is cycle. No? Division of bacteria. Okay, that's the only thing. Maybe that part. Domino effect, not really. Maze solving, no. Don't give me problems. Tell me real world things that you do which is recursive. Dream into dream. Okay. I understand what you're going, where you're going. Okay. Tower of Hanoi is solved with recursion, but it's not recursive. Okay. Okay. So you are giving me coding examples. Don't give me coding examples. Okay. Tell me real world. No, kuch nahi hai. Okay. Don't worry. Nothing. Yeah. Population growth might be one thing, but in general, nothing in general is recursive. That too is exponential, but it's not recursive. Okay. Chasing goals. That has no base case, no. Chalo. So we have recursion, but we understand recursion that there is some sort of dependency that needs to be resolved. 5 calls 4, 4 calls 5, and 4 calls 3, and so on. And that gets you the value that is required. But somebody came in and says, Ki Vivek, okay, recursion was good, but I want to be smart around certain things. For example, I'll give you a quick formula. This is called n choose r, right? Do you know what is n choose r? Everybody knows, yes or no? Quick plus 1 minus 1. N choose r, pata hai? What do you know? Do you know what n choose r is? Plus 1 minus 1. Okay, so n choose r is basically how to choose r items out of n. So there is 1, 2, 3, 4. Choose 2 items out of this. A very simple way to think about it is like 4 choose 2. Out of 4 items, choose 2 items. Either you will take it, so you will have to choose r minus 1 items out of n minus 1 items, or if you don't take it, you will have to take r items out of n minus 1 items. That's exactly what the formula is. If you take this, this is the formula, plus there's a disjoint way of not taking it, this. So there is this formula which is used for recursion. Okay. And there are many more functions like this. Fibonacci would be one more example, which I think you would have seen multiple times. But Vivek, why are you showing me these things? Why is this so boring, right? This is all boring. I'll actually show you a very interesting stuff, okay? Let's see if you guys are able to relate to this. Do you all know what Fibonacci is? Fibonacci series? Yes or no? That what is the value of Fibonacci of 3? It depends on 2, it depends on 1. Fibonacci of 2 is nothing but Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? So you basically have this graph by which you decide how to get the value of Fibonacci, right? So there were many more recursions like this, but then people decided that, okay, I want to calculate it for larger values. So people thought, let's calculate Fibonacci of 7. And obviously there is a recursive function which will calculate that value for sure, right? There is going to be tons of values which is going to get you the required return value for every state. Here, Fibonacci of 3 is 2, Fibonacci of 4 is this, right? And I'll just speed up the process. This is how Fibonacci is actually calculated, right? Fibonacci of this is actually calculated this way. Okay, this is how the recursion will actually run. Okay. Fibonacci of 7 is actually 13. How do you guys see this panning? Because in case of Fibonacci of 7, we calculated these values, but ended up recalculating Fibonacci of 4, 3, 2, 1 so many times. Fibonacci of 4 was calculated here, but it's being recalculated over here. Fibonacci of 3 was calculated here, but it's being recalculated over here, right? That is what somebody realized here. In recursion, there is so much of overlap that a lot of things that is already solved gets repeated. So somebody thought, okay, why not make it really interesting? Let's take one more example, like n choose k, right? I'll just, so very similarly, there will be a graph for this also. Like if you're calculating for a certain n choose k value, this will also have a graph like this. This is called recursion graph, right? Recursion tree, that what states are you visiting? Okay. Very similarly, binary search, GCD, anything that you can think of, they will all have a graph. Okay. Let's go back to the one that we were talking about, which was Fibonacci numbers, right? This was the graph. So in Fibonacci, what somebody realized was, hey, let's not go around calculating it like this. Why not, when we get certain value, we save it? So we thought of, instead of doing this, we thought, let's do it this way. That if we know that 2 needs 0 and 1, let's have a single time calculation, save that value once and reuse it when we need it, right? Next 3 will get the same kind of value like this. 4 will get the value from 2 and 3. So instead of going from recursion tree, what we moved into is something called as recursion DAG. Okay. This is something that you guys will have to realize is what actually DP does. Unless you see this, there is no point in learning DP. Most people don't even realize that this is what is happening. They just try to memorize. Acha, ye formula. This is how knapsack ka formula. Ye पढ़ के कुछ नहीं होने वाला. There is nothing that you will ever be accomplishing. Okay. Realize what truly is happening behind the things. Okay. Memorizing solutions will not get you anywhere. Okay. Memorizing codes might help you get somewhere. Okay. So DP is nothing but solving on graph, which is a DAG. Okay. And maybe doing certain important things. DAG is directed acyclic graph. There is no cycle in this. Okay. There is no cycle in this. DAG is something that doesn't have a cycle. Okay. There is no cycle in this. See, because every node over here depends on 2 values. Okay. There is no cycle. That's it. There is an arrow in every edge that 2 depends on 0 and 1, but there is no cycle here. Okay, so this is called a DAG. So from this, calculating these many values, we went to this, calculating only these many values. And that is the true optimization DP brings you. This is what DP is actually good for. When you have a big tree like this, and you suddenly want to memorize that, or you want to make it optimal or optimize that, you can say, you basically want to calculate everything only once, save all these blue nodes where you are calculating it again, even if it's calculated that when the value of Fibonacci of 4 is 3, it will always be 3. So why to calculate it again and again? Okay, so this is essentially how things run, and you are going to realize that this is what will make it super optimal. Tabulation is such an, it's a tool, it will not get you anywhere. Okay, there is no funda of tabulation that comes in DP. Okay, it's just a tool that you use at start. Okay, to see the picture, how it's calculating the values, but tabulation comes later. It's actually recursive codes that are being converted into directed acyclic graphs. Does this make sense to everyone? Can I have some number of plus ones if this is making sense? Plus one if it's clear, minus one if it's clear. That some tree is getting converted into some sort of smaller graph with smaller number of nodes, so that things are not calculated again and again. Is this making sense to all of you? Quick plus one if this is clear. Great, chalo. I think super happy to see this. DAG, nothing, kuch nahi. Tree converted to a graph which has small number of nodes. That's it. We don't need to know DAG. What is a DAG for now? Let's come back. So this is the visualization of magic that this is the magic that DP builds in when you try to visualize it. Ki so big of a tree, and believe me when I say this optimization is actually going to be transformative as the values of n become large, because when you have 10, and let's suppose you are building recursion tree, this is how the recursion tree looks like. This is how recursion tree looks like. If I just like, this is the tree and the DAG will look like this. Do you understand the order of magnitude by which it is reducing the computation? Yes or no? I mean, are you able to appreciate the order of magnitude? Quick plus one if this is clear, because you will never be able to learn something good out of anything unless you're able to appreciate how good of a technique that is. Okay, yeah, so first of all, we're going to learn with recursion only. Tabulation is things that you learn later. It will just build you tools to be able to see things. Okay, tabulation isn't something that people go on places and see, acha ye tabulation hota hai, ye hota hai. We'll talk about them, don't worry, but fundamentally it's just recursion being optimized, right? That's all what is there. Okay, so it's essentially exponential to linear conversion, right, to some degree. We'll talk about these, don't worry. Okay, so there are two fundamental properties in a problem that needs to be there. One is optimal substructure, which I fundamentally think is a pseudo property. I mean, I have solved problems where it might not follow. Okay, I'll explain what this means. Okay, let me go back and actually show you that visualization once more for one more example. Okay, everybody knows the formula called GCD of A comma B, that this is the GCD. Okay, so when you have like, let's suppose two values and it's calculating GCD, right? This is the sort of like graph that you are getting, right? Simple graph. And if you are converting it into DAG, it remains the same. Do you think it will give us any optimizations if we try to use DP in such a problem? Yes or no? Do you think this will give us any optimizations? Or think of the very simple example, factorial of 7. The recursion tree looked like this and converting it to DAG looks like this. Will it give me any benefit if we use DP on this particular problem? Fundamentally no, right? Because there is no overlapping. There is no node that is being repeated. But in case of factorial, there was Fibonacci, there was tons of nodes that were getting repeated. That this was such a big of a tree. I mean, I think it cannot compute for 16. Okay, I think it got hanged. It's so big that it's not going to be able to do the calculations. Okay, this is how it looks like. It finally drew it, by the way. But this is how big of a tree it will build if you use Fibonacci for that. Let's build for 10. 10 should be manageable, right? It will look. Oh, I don't need this. Right, this is how it looks like. In this, there are these blue nodes which are recomputed, right? See over here, number of sub problems visited and number of sub problems repeated. Almost half of them are repeated. So in this case, we can actually just make use of DAG and make it optimized. So we are able to only optimize when something is being recomputed. So don't come and tell me, Vivek, can I use DP on every problem where you have a graph, or where you have where you have a recursion, or when you are using backtracking. There's a topic called backtracking. You might have heard about problems, n queen problem. There is a board, place queens on it. There are solutions for that in recursion. Can we use DP for every problem? The answer to that is, does it have a repeated state? Yes or no? It turns out no. Okay. So only problems where things are getting repeated is where we can optimize. So to be able to apply, the first very, very important condition that has to be there is there has to be some sort of overlapping sub problem. This is absolutely necessary. Is this clear to everyone? Yeah. So without that, there will be no benefit in this. Clear to all? Quick +1 till this part. If this one is clear, overlapping sub problem is clear. These two terms, it's often asked in sometimes in interviews, sometimes in theoretical courses. Jaan lo bas. Anyways, we'll not need them to solve problems, right? Okay. So we have optimal substructure property. That's another property that is often helpful to understand DP problems. And the idea that it encompasses on is, see, there is some particular function of, let's suppose, x, which is dependent of f of y and f of z. Okay? And we are saying that x depends on y and z, just like that tree and DAG we talked about, right? Now the thing is, when you have this, okay, if a certain value is dependent on these two, they are dependent on their optimal values. Suppose they are asking, find the minimum value in the array, or find the optimal value, find the optimal way to partition an array, or find the optimal way to choose a single element. In this part, whatever is the optimal, in this part, whatever is the optimal, you will get the final answer by merging the optimals only, not just any value. Okay, you don't want suboptimal values to merge and give optimal value for this one. You want only optimal values to merge. Okay, but it becomes a little confusing in this way, right? It looks a little confusing in this way. It's not 100% clear. What is optimal substructure in that case, right? When we will see a problem, I will explain you this very, again, that what optimal substructure means. And there is so much of value. Okay, why this is of so much of value? Okay, clear till this point? Overlapping sub problem clear to everyone? I think I'm going a little fast, slow. Achha, quick feedback. Pace, good, bad, theek, whatever you guys feel like. Let's see. Accordingly, I'll just tell. Go fast, go slow. Understood. Sahi hai. Okay. Can you teach suboptimal? Yeah, I'll explain when we see an example, because these see, theory makes no sense unless you see a solved example. Okay, I am a person who never learns from theoretical things. Okay, show me the example, I'll be able to figure out how to solve a problem. Okay, show me 5 examples, I'll be able to figure out how to understand what this term means. Okay, so we will learn this in actual problem. Okay, now this is 2 words which I think many people use. I don't know why they kind of fight across it so much. Vivek, top down or bottoms up, which one to use, right? Okay, so there is 2 ways to implement DP functions. One is, say you need Fibonacci of 10, right? You basically say, hey, get me 10. 10 will say I need 9 and 10, 9 and 8. 8 will say I will need 6 and 7. 6 will say I will need back these. And then this recursion of demand will fill the previous values, right? 0, then 1, 1, 2, 3, 5, 8, 13, like these kind of values will get filled accordingly, right? That when you require n, if these values are not calculated, go and get those values calculated and saved in a memo table. Okay, this is a separate array in which you are saving the value. Don't go into code right now. I'll teach you how to write codes also recursively, and it's super simple. If you understand it once, there will be no going back. Okay, once you understand what I'm teaching in the next two problems, next at least one problem only, there will be no going back from having clarity of DP. No, you will never be able to say कि DP समझ नहीं आता है, right? Let's go to that state slowly. When you are at this place, you want to calculate this value, you are dependent on two different values previously that are over here. So you pull those values कि भाई calculate करके लाओ and tell me those values and I'll use that, right? So this is essentially what DP calculation looks like. This is called top down. Start ऊपर से करा, we go down and fill these values. There is another one which is bottom up, which is I know that I need this value and the previous values will be required. Okay, so over here, start filling the things from the lower side only. That hey, fill this 0, fill this 1, fill all these things, fill this in a loop, and then I know that everything I need is already calculated in the table. This is called bottom up. Code not clearly visible. You don't need to see the code actually. I mean, if you can zoom in, I can zoom this part, but I don't think this will be much of help anyways. I mean, you don't need to know the code. ठीक है, कुछ नहीं, loop चला के we are filling the array. That's it. That's all we are doing. Okay. Clear, everyone? Great. Clear till this point. This was the beginner part of today's session. I just wanted to make beginners also feel little welcome कि भाई हाँ समझ में आ रहा है, right? Even if you knew it DP from the basic part, even if you did not know recursion, you could understand. But next we'll move towards solving problems. Before that, how many of you like vote for which one? Which one is better? Top down or bottom up? Which one? I mean, I was just going to do bottoms up, but ये नहीं करना है अभी. We just want to solve problems for now. Which one is better? Depends. The correct answer is depends. Okay. The correct answer is depends. We basically want to make sure that we are understanding the difference between the two and which one to use. Okay, so it might be the case that you might say bottom up is better because we know that we are going to need all the values, right? And some people use bottom up, some people use this. I always recommend using top down when you are learning at the start and then going bottom up when you have become a little pro at DP. Reason being because top down is naturally recursion, and unless you become good at recursion or designing recursions for DP, you can never truly become good at DP, which I'll teach you, obviously. Without that, I'll not leave you today, okay? When I'm saying something that I'll actually make it simple for you, I would make sure that happens, okay? So, when we have a problem where calling this, you know that Fibonacci needs all these two, this also needs these two, this also needs these two. So eventually everything will be filled and all the data is needed, then maybe bottom up is better. But there might be a recursion as simple as f of I is equal to f of I by 2 plus f of I by 3, something like this, right? In this case, if you have 10 being called, 10 depends on 5, f of 5 and 3, right? 10 by 3 floor division, let's suppose, right? So 10 by 3. So in that case, you will only need the things that are required. 5 by 2 is 2, 3 by 3 is 1, and things like this, right? So you will only need things that are required. So in that case, top down becomes more optimal when all the states are not reached. And my fundamental idea is let the recursion decide na ki what it needs to find out. Usko jo legega wo nikal lega. It will find out whatever is required. Okay, you just plug in play. Let the recursion decide what it will want to find out. Okay, clear, everyone? This is called bottom-up DP. Is this making sense to all of you till this point? Quick +1 if this is clear. This is the difference between bottom up and top down. This is bottom up में पूरा भर रहा है, top down we are going back and on demand. Top down is what we will focus on a little bit. Yes, but top down will only take as much space as the size of the memo, no? Because क्या मुझे उतना ही वैल्यू सेव नहीं करना है? That many states are there only, no? ठीक है. So this was the phase part 1 where I wanted to talk about basic recursion, DP के कुछ terms, right? But I think very little value is built on theory, examples, ये सब चीजों पे. The real learning happens when you learn how to solve a problem. ठीक है भाई, विवेक सिखाओ मेरे को how to solve a new question, how to think about DP, because everybody will say कि okay DP ये है वो है, but the true thing that you need to learn is how to think on a DP problem from first principles is what we will learn today. Okay? And I'll show you a very interesting problem and I'll try to deep dive on that. And you might have seen problems like knapsack, coin chain, all of these will become easy with just one problem. Okay? And I'll teach you how to design solutions, not memorize solutions of DP, which I think most people do at the end of the day. Vivek rat lo isko. Okay. Chalo, next, let's move to the next part. Before that, I think this is a good point if to maybe I'll see if I can actually get this. Why is it not getting pasted? I wanted to show something, but weirdly enough, it's not. Let me just quickly do one thing. Why is this taking so much time? The QR code you guys are waiting for. Is DB possible in C language? Yes, it is possible. It doesn't need, it just needs basic recursion. Next, I'll teach you the most interesting part, which is how to design solutions. And I think you'll enjoy it. Basically, framework of how to think about DP. Types of DP, we'll come to that. Everything is same, it's just different forms that you have to know. Okay. But before that, you need to know how to design solutions of DP. That's what I'll teach next. Okay. Scan this QR code real quick for attendance. Okay. So I'll give you guys quick 2 minutes break. Tab tak we can discuss, take questions. Types of DP, if you have any questions and stuff, please increase speed. Yes, we'll do that, don't worry. If I come to speed, then most of you guys will fail to keep getting forms. Why do we need forms? Because you want to be able to solve questions faster. That's why. So we'll talk about framework, which is how to think about DP problems when you see them. And forms is like what different types of DP problems. Like you might have heard about, right? Knapsack problem, interval DP, things like this, bit mask DP. You might have heard about these things. Okay. करेंगे भाई, don't worry. अभी तो start करा है. Why are you guys so worried कि विवेक होगा कि नहीं होगा? सब करेंगे भाई. तो start करें. Any other questions that you guys have for me? Quick 2 more minutes, then we'll resume back with what we were doing. The next part is the main part. Vivek, कुछ magic सिखा दो. Next, I'll teach you magic. Because I just want people to drop off who are here only for attendance. Where to scan? Mobile पे, maybe. If not, then you will get the link. Sir, आपका number ये तो ना मिल सकता. Sir, what is your CF URL? CF, you can find me on all platforms with the handle AC Raider. Okay, if you want to find me on. So I no longer compete. I mostly teach now. So I'm more in the coach mode now. Okay, so that's a different life altogether. I didn't understand top down and bottom one. करते अभी top down अभी बनाएंगे solution, then you'll understand. Number only for girls नहीं, किसी के लिए नहीं. Don't worry. कमी नहीं है दादा इधर. Yes, coach mode. Yeah, obviously I'm master, so I can easily international master, so I can easily use coach mode. Yes, coach doesn't play competition. I don't participate now, but I often take, like on YouTube, I take discussions on Lead Code Weekly on certain interesting ideas, and that's what you can also join in if you want to. Right? सारी हो जाए. यही करना है आयो हाँ. What is Codeforce's profile? You will get the descriptions of all these things as you go through the camp. Okay. DP workshop. So the camp is basically multiple instructors taking different classes. So this is like my class, then there will be more people taking next classes and stuff. DP workshop was on YouTube. It's like I took it 2 years back for those who are asking. I took it 2 years back. That content will still be relevant. You guys can watch that to improve further, like different forms that I'm going to talk about a little bit. What is CF profile? Payments are for graphs and trees, please. करेंगे. We'll see. Okay. Quick problem in your screen. Okay. You guys can see the problem now on your screen and the link to the URL to the form also if you want to write that. But I think you'll not be able to copy it from screen. No? It'll be super hard. Attendance मिल जाएगा, don't worry. I'll give you that at the end also. जिसको attendance के लिए रुकना था करके चले जाओ. I don't want them in my class. Next, जिनको पढ़ने आना है आ जाओ next. ठीक है, अब असली चीज सिखाता हूँ तुम लोग को, right? Choose to loop start. Okay, I'll teach you a framework which will make your DP almost next to perfect. How to do that, Vivek? Yeah, I use G. पढ़ाई पे ध्यान दो सब. Yes, चलो next. अब मूव करते हैं. Fractional knapsack भाई नाम से कुछ नहीं होने वाला. There is no name required. Okay. नाम कम याद करो, काम ज्यादा याद करो. ठीक है. How to actually solve problems. It's super important. Read the problem carefully and try to think about how to design solutions. So basically, this is saying that there are n items in front of you. Each item has a weight WI and a PI profit. Okay, this is a very standard. There is a problem called knapsack. Okay, but I have modified it. Number one is you have a big bag of weight. You can take at most capital W weights. Look, the sum of weights of item that you pick has to be less than equal to capital W, and the number of items that you take has to be less than equal to K. Okay, you have to maximize the sum of profits of items taken. You have to maximize the sum of items, profit of items taken. Okay. How will you decide which items to take and which items to drop? 20% question clear, कुछ कुछ समझ में आ रहा है what we are trying to do. Let's take an example. I think that would be making it much more clearer. So let's say some items are there, like 1 with a profit of 3, an item with weight 5 with a profit of 2, and an item with weight 2 with a profit of 5. Okay, and you have a bag which has total weight 6. Which items should you pick in the bag so that you don't exceed the sum of, these are the weights, these are the profits. So one way is you pick this item and this item. So if you take these two items, the sum of weights is 6, so it's less than equal to 6. That's fine, that is given to you. And the value of K is 2. You can at most take 2 items. So you will take this item and this item. So in this case, the weight is matching, and the sum of profits is 3 plus 2, which is 5. But I think you can do better by dropping off this and actually taking this one, because now the sum of weights is still 1 plus 2, which is 3, which is less than equal to 6. Number of items is still 2. You have not exceeded the limit, which is K equal to 2. And then 3 plus 5 is 8, which is the maximum profit you can draw with taking 2 items and having weight less than 6. Okay, so you want to be making sure that you don't exceed your weight limit, the capital W given in the problem. Okay, you don't want like the number of items to exceed a given K in the problem, and you want items that you pick has maximum sum of profits possible. Is the question clear to everyone? Quick +1 in the chat. This is the question. Now you can read it again, and I think it will make much more sense. No, only once. Matlab, either you will take it fully or not. Exactly once. Okay, either you will take it as a whole, the whole W, or not. Okay, there's no fractional and stuff. Okay, I'm not taking a theory class. You will learn in this in your college ki fractional knapsack, free knapsack. ये सब नहीं. We learn to design solutions, not to go through history and Thomson model, Bose model, Rutherford model. ये सब नहीं करना है अपने को. सीधा टेक्निक सिखाओ, है ना? Constraints. Let's say open constraints for now. If you want the constraints, let's say everything is still. कुछ भी ले लो. It's open constraints. Let's say 100. Everything is still 100. Okay. Your weight is still 1000. All the weights are till 1000. Constraints is not important. Okay. Now I can guess already that people will start throwing names on the chat. Ki bhai, cadence algorithms, brute force, recursion. Okay. Is that what you do when you see a problem? When you see a problem, what do you do at the start? कैसे सोचते हो? Like, how do you even think about solving a problem? ये problem देखा. What do you think? Maybe some idea is there. Like, maybe greedily trying some profits might work, which will not work in this case. Like, maybe it might work over here, but if I swap these two values, maybe it might not work. Right? If you just swap these two values, if you try to pick the items which has the highest profit, you will pick this, and then like let's make this 5. Okay, weight is equal to 5 and k is equal to 2, and then you cannot pick anything, but rather a better way would be to pick these two, so get a better profit. So greedily trying to pick the maximum profit will might not work. One more thing that people think when you see the problem, see, today you don't want to learn कि विवेक इसका solution क्या होता है. Try to understand मैं सोचूं कैसे. If you can understand that one thing, you will be growing very, very fast. Listen to me very, very carefully. No, sorting will not work. Okay, I'm not trying to give you anti-test cases for all ideas. It will not work. We are trying to go in the direction of recursion. How to design a solution that will recursively work for this problem. Okay, but Vivek, how do I think about such a problem? First of all, okay, I think one of the problematic things that people do at the start, I'll just quickly. Why is this? Why did the board crash? Super weird. I'll just quickly get it up again. Really? I think something crashed. Let's go back. Okay. Generating all possibilities. Yeah, that is obviously an option, which is brute force, but we want to do it faster than brute force now. So, how do you think about a problem when you are thrown at DP? Okay. Because case by case, pick or not pick, and memorization to optimize it. Knapsack style, just save the key item that might do. How will you do that? Check. So when you think of a DP problem, right, what I'll give you guys an advice is try to read the terms very, very carefully and try to design the solution in steps. First thing, you are trying to build a solution, right? Out of these items, you will take certain items and stuff. What are you building? Are you building a subarray, a subsequence, or a subset? Choose out of the three. Are you choosing a subarray, a subsequence, or a subset of the items given? You can say subsequence also, because in an array, subsequence and subsets are almost the same. It's like taking or not taking certain things. So, but I'll say subset, right? You're dealing with subset to some degree, because order doesn't matter. Just the profits and stuff matter, right? Because individual items, weights and stuff matters, but their ordering don't matter. So subsequence means order matters. Subset means order doesn't matter. So first thing that you realize when you're dealing with any problem is, number one, subset, subsequence, subarray. Tick one. Most of the times you will have one of these tick. I'll tick subset, right? Because you're dealing with subset. Second thing is it a counting problem or an optimization problem? Counting problem or an optimization problem? Bad handwriting. I'll improve. Optimize. I'm not a doctor, right? So I should be better. Chalo. Optimization or counting? What we are dealing with right now, are we trying to count all possible ways to build this? No, we are trying to maximize. Whenever the terms are maximize or minimize, we are dealing with optimization. Okay? Whenever you have to minimize or maximize certain process or certain choices, you are dealing with minimization or maximization wala problems. This is a optimization problem. Counting means count the number of ways in which you can make certain profit or something like that. Okay? Count the number of ways you can place n queens. Count the number of ways you can select a subarray. Things like this. Right? They are counting problems. This is an optimization problem. Okay? Fine. So now you know that what kind of problem you are dealing with. Next in DP, what you try to understand is, what is this subset? So you start thinking in terms of a specific idea, right? That you need to see, like knapsack or stuff. But what I call as form one, let's say, is what you try to think about is, you have bunch of items, right? W1, P1, W2, P2, Wn, Pn, right? To build a subset, how do you get there? For every item, you have a choice that whether to take it or not take it, whether to take it or not take it, right? That's essentially how you build subsets, right? Yes or no? Is this how you build a subset? For every item, you have a choice of take it or not take it. In fact, 2 to the power n number of subsets comes from here only, right? Every item has two choices, so 2 to the power n number of subsets, right? So we are dealing with this problem where you have options for every item, whether you have to take it or not take it. Okay, this is essentially the setup. You want to be able to find the optimal setup, optimal choices for all the items. That's what we are trying to do, right? That's what we are trying to do. Okay, great. Form one, we have a collection of items. We want to take certain subset out of it. Every item has a choice to take it or not take it, but we want to do it optimally. Next thing that you try to think of is, why is everything not feasible? What is restricting you to be doing all 2 to the power n tries? One is obviously like complexity will not pass, right? The second is, why is every subset not feasible? Is it because of these two constraints here? It's not constraint of the values, it's the constraint on subsets, that whether it's feasible or not, right? Whether it's allowed or not, right? These are the two that is making our life hard. I mean, or else we could have just taken every item that was positive profit, take it into our account, and we would have gotten a profitable like set, right? But just because of these two restrictions, it's becoming harder, right? So this constraint is what is making our life hard, right? Yes or no? Clear till this point? This is just initial observations and notes that you are kind of building on a problem. People say, no, observation, quote unquote. This is what you observe in a DP problem, that it might be a DP problem. You have a subset to be built and you have to optimize certain things. You have this setup of form one where every item has a taken or not taken. And why not everything is feasible? Because you have two restrictions. If you can do this for any problem, almost every problem is solvable. Next steps are mechanical, which is just doing the same thing again and again. Vivek, what is that? Teach me that, right? That's what that is what I call as framework. Okay, that how to next technically just convert this to a solution, right? So what will be my framework for solving a DP problem? You have a setup that every item can be taken or not taken. That is your form one. So next step one will be do these observations. Ki it's a subset being built. You, for every item you're taking taken or not taken, right? And you are building this particular setup, like that. This is what you have to do. You are recognizing the restrictions and stuff. So you basically, this is what I call as recognize the form. Okay, recognize form. Okay, and this is basically this form. Take, not take, take, not take, and you have to build a subset. Very, very simple to recognize. Everybody was able to do step one. ये तो बहुत simple है. Everybody can understand this. Quick +1. We'll do step by step, and any problem can be thrown in the same steps. First, recognize form. This is form 1 problem, which means you are dealing with bunch of items. You have to build a subset. Every item has take, not take choice. This is clear to everyone, first of all. Okay. Great. Next, step 2, design the DP recurrence. Design recurrence. Okay. Yeah. So there are 5 fundamental forms, few advanced forms that you learned with practice, but every form will have the same steps going forward. Okay. So design recurrence. How do we design? See, I'll teach you a very interesting way in which will make your life super simple. So we will write DP, okay, over here. This is what people find super hard. Vivek, how will I write the recurrences? How will I know the recursion mein I, J, K lagega, kya lagega? People make it super hard, whereas it's super simple. Okay? Firstly, you need a process to generate all subsets. One way to do that is go to a particular item and decide to take it or not take it. Based on that item choice, you will go to the next item. So you are basically branching off. Hey, I have my current item and I have a choice that can I take this or not take it? Take it. Okay, then next item choice. So over here you can take, or you can do this, take, not take, take, right? So you can decide this item and then rest of these items can be decided later, right? यहाँ तक समझ में आ रहा है? If you take or not take, depending on that, you can decide what to do later. इसके बाद यहाँ तक clear है? That depending on the choice, things will change forward, but you can decide here and then move to the next item. One by one, I can decide, and then eventually I will get a subset. This is a process to generate, right? So I will say DP of I. I means which item I am currently deciding to take or not take. First state. Is this part clear to everyone? Which item I am currently deciding, yes or not, take or not take. Is this part clear? यहाँ तक clear? First state, for every item I have to decide. So let's say I'm at the ith item and I'm deciding whether to take it or not take it. This is my first state. Okay. This comes from the form. Like every form 1 problem will have the same first state. ठीक है, जिसमें भी take not take वाला आएगा, knapsack, coin change, कुछ भी ले लो, it will have the same state. Okay. Next, what do we want to return from the DP? Every DP function wants to return something. Okay. What do you return? You want to return something that that was asked in the problem. क्या पूछा गया था? Maximize sum of the profits. Okay. What will be returned? Maximum sum of profits from items I till n. Because I am right now at I have already decided the previous items. तो उसका मुझे profit नहीं मिलेगा. I cannot get those profits at all. I am at the ith item, so I can decide to take it or not take it. And accordingly, I will get this and the future profits. So what is the maximum sum of profit, quote unquote, what was asked in the problem for items I to n? And this part, what to return, comes from what was asked in the problem. In 70 to 80% of the case problems that you will see. If you're dealing with interview problems, probably 95% of all problems will have the same return type of what was asked in the problem. Okay. Maximize sum of profits. So what we will do, we will return maximum sum of profits for the part of I till n. This is called optimal substructure. Optimal of 0 to n depends on optimal of I to n. Remember, there was a term called optimal substructure. You can make it from 0 to I also, it doesn't matter. You can do it that way also. I just write it this way. यहाँ तक clear? This is making sense. Quick +1. यहाँ तक अगर clear है तो I need +1 first because checkpoint करते करते चलते हैं धीरे धीरे. Then only it will make sense. I want you all to be good at DP because DP is something that people fear. I don't know why. Maybe because it's a little harder, and it takes practice. But if you understand the core building block, right, it becomes super easy. So I'll explain the optimal substructure and all these things again a little later. Okay, don't go back to this. I just mentioned it once. I'll come back and explain it again. Okay, maximum ये जो items है from I till n-1 जो बचा कुछ item है, I am at ith item. From here till L, I have to decide which item to take or not take. For each item to take or not take, I will get certain profits. जितना maximum बना सकते हो, I can get that. Okay. But now comes another restriction कि भाई can I take all items? No. So now tell me what helps me decide कि whether I'll be which items will I be able to take and which items will I not be able to take. Let's say you have n items. You are at the ith item and you are deciding किसको लेना है नहीं लेना है, फिर इसको decide करोगे, फिर इसको decide. You will decide these items, right? So it depends on, first of all, capital W and capital K कितना restriction था, right? It depends on these restrictions. It also depends on how much you have already taken. Yes or no? It depends on how much you have already taken also. So I can try and keep it this way that, okay, maybe try keeping how much weight I have already taken and how much K I have already taken. You can keep it this way. Whatever will help you decide ki can you take it or not. To manage the restrictions, you try to put them in the state. This is how you design states. Okay? People find it hard to design states, what to keep in states. This is called states. The argument of the function is called states in DP. How do you put these? Whatever will help you decide कि इस item को लेना है नहीं लेना है. Okay? Because if you know how much weight you have taken and you know the limit, which is by the way constant, like for a problem, you can decide कि अगर limit cross नहीं हो रहा, then I can take it. Clear everyone? Yes or no? How much weight I have taken, how much items I have taken. If I maintain that, I will be able to decide, no, can I take the next one or not? Because if it is in the permissible limits of the weight and if it's in the permissible limits of the number of items, then only I can take it. So these two states will help us manage the restrictions nicely. So this is called state designing. This is called design recurrence or state. Okay. This will come from the form which you are dealing with, like subset. So go over every item and decide to take it or not take it. This part will come from restrictions, or sometimes it also comes from transitions, like the movement that you do, but mostly restrictions only. Okay. And the return types comes from what is asked in the problem. %95 of your lead code problems is just this. Okay. Which form we are currently on, how much weight I have already taken, how much K I have already taken, tells me whether I can take the current item or not. And based on that, I will move forward. And this is how it should be. Right? Is the step 2 50% clear to everyone? 50% I'm asking, I'm not asking for 100%. 100% agar ho jata to I would have been God and you also would have become God. 50% is clear to all of you or not? Yes? Great. Nice. So that's super good to see. So many people interested in learning DP. hard content. So this is weight taken and K taken. This is how you design this. Next step, step 3, design transition. Okay, design transition. How do you do that? Very, very simple. Now, once you have the states, this step becomes easy. How? See, what is the picture in mind? You are having some number of items. You are at the ith item. This many items, out of these, the total weight that I have taken is this, and the item number of items I have taken is this. Okay, I am at the current item. For this, I have two choices: take or not take. Right? This is my setup at this point in time. Should it be W left, or are we maintaining W? Yeah, W are global value, so we can do it that way. Actually, lefts might be a little better, but not for today. I mean, I'm just teaching you how to design. Okay, कुछ भी बनाना सीखो. Don't be restricted on solutions that you read at one place. Fundamentally think how can I design even something different? Why is something working? Why is not? Because if you aren't at that level, you cannot really solve new problems on your own. You will only be memorizing solutions of वही 5, 10, 20, 40 repeated problems that comes on lead code and think कि DP आ गया, but फिर नहीं होगा कुछ. That's what most of India is at this point in time. ठीक है कि 40 known lead code repeated problems जिसके videos YouTube पे होंगे, सबको वही समझ में आ रहा है कि वही solutions उसके रटे हुए हैं, but it's not that. Try to understand from first principles how to think. Okay, please use a different color. Okay, it's a little less legible. Okay, I'll not use red much. Okay, yellow is better. Yes, you can think it that way also then. So we will say dp of I have taken this much. I have taken this many items. How many items I have taken? From here, what are my two choices? Okay, take or not take. Okay, these are my two choices. Based on this, I will design my transitions. If I take, which state will I reach? If I take it, I will naturally go to the next item, I plus 1. So I will go to this state, I plus 1. Okay. If I take this, how much weight have I taken? Whatever I had taken earlier, W taken plus, I am writing it this way, W taken plus whatever was the weight of this ith item, W of I. This is the number of weights, that total weight that I have taken now. And how much items have I taken? The number of items I have taken earlier plus 1. Is this what is essentially the configuration that we are going into? Quick plus 1 if this is making sense. I know it might be getting a little harder slowly, but try to bear with me. The more growth happens when your brain is trying to fight you कि भाई समझ में नहीं आ रहा है, but then you are trying to push it कि भाई समझो. That's when you grow. Okay. Right? When you are at an ith item, you are deciding to take it or not take it. So if you take it, the taken weight increases, number of item taken increases, right? If you are not taken, then in that case, you will go to this state, dp of I plus 1. I have not taken anything, so whatever weight I had taken earlier, that much weight only I'll have. K taken is this much, right? So this is basically the two configurations that you reach to. And if you take, you get a reward. What were we calculating? Remember, go back to the definitions. Definition was saying maximum sum of profits from I to N. So this should give me profits from I to N. If I go not take, then I will not get any profit from ith item. But if I take, I will generate a profit of P of I. Right? If I take, I will generate this. But if I don't take, I'll get plus 0 for this item. Right? Is this diagram making sense to everyone? This is in fact what you need to think in your mind to design transitions. And it's simple, no? Like naturally what jo kar rahe wahi kar rahe, that's what we are doing, no? Jo track karna hai, maintain that thing as we go forward, right? If you take it, you will get a profit of that item. If you don't take it, you will get 0 profit of that item, right? By the way, guys, if you have not realized this, we are already done with the problem. Okay. So this is essentially the recursion. This is, if you have written this diagram, you will be done. One final piece is you need to merge these two solutions, right? At this point, I have both the options. Which one should I pick? Which one should I pick over here? Max of them. Perfect. I should pick max of them. If I pick max of both, because whichever ones leads me to the better profit for the ith one, I will take that, no? Bus, this is the whole diagram. If you have built this and if you have this in your mind clearly, you are done with the problem. This is essentially all of DP. Simply designing the form, thinking of the form, designing the states based on what you need to design, which configuration you are in, how would you be able to manage the restrictions and stuff. Okay, and this is what you write as this. Okay, but this will be 2 to the power n. Yes, it's 2 to the power n. Coming to that, don't worry. I'm I'll get you guys to the point where it is no longer 2 to the power n, right? Why max? Because I had to maximize my profit. तो अगर लेके प्रॉफिट जो मिला, नहीं लेके मिला, दोनों में से जो बेटर, whichever one is better, I'll take that. If you take and whatever profit you get out of that, if you don't take whatever profit you get out of that, you want to take best out of both, no? You will take maximum out of both. जिसमें max मिलेगा वो ले लेंगे. That's being greedy at this point in time, but that's being greedy knowing the perfect information that if you take it, how much maximum you can generate. These DPs are giving you maximum with all possible future recursions, with all possible future choices. So if you have perfect information that if I take it, I will get this much, even if I do best. And if I take this, I'll get this much, even if I do the best. Why will not be greedy at that point, right? So this decision is greedy, given that you have perfect information over here, obviously, right? It feels like greedy, but it is greedy. Okay. So this is essentially the step 3. Step 4. What is step 4? Optimal substructures. Substructure to ho jayega. It gets managed automatically by this design of steps only. Where we are adding this P of I before taking max. Like this branch will give you Pi plus this much. We'll write the expression, don't worry. But before that, even before trying to write the code and stuff, there is a step 4. What should be the step 4? Do you know? TL check, time limit check. Bhai, will this code even pass? नहीं. Will this code even pass? भाई इतना लिख लिया, कोड लिखेंगे, पास नहीं करेगा, क्या फायदा होगा? है ना? So you should check whether this code will pass or not. Base case and stuff, तो implementation details है, right? They will be get handled in implementation. Whether it will TLE or not, TLE check you can say. Okay. Time limit check. How to do TL check? There is a simple formula. Number of states into 1 plus number of transition or average transition is the complexity of your code. O of this. This will be your formula. Number of states into 1 plus average number of transitions. This is a formula for you. Vivek, what is number of states? देखते हैं. I'll actually write. I'll zoom it out a little bit. Okay, this is the states that we designed. So I'll write it. I'll zoom back down in. I'll write it over here. DP of I, W taken, how much weight you have taken, K taken. Okay. What is the possible values of I? 0, 1 till up till n values, order n values. W taken 0 till up till capital W because you cannot go above the limit. Items taken 0 up till K. These 3 things. Is this what you need to get in every DP problem? States that what are the feasible ranges of the functions arguments that you're designing in DP? What are the ranges it can take? And this is n w k, so the number of states will be n into w into k. I mean, don't need to add +1 and stuff. Order notation hai, so they will get reduced anyways. But is this making sense कि इतने सारे states हो सकते हैं? These are the number of feasible states that you can essentially reach to. Quick +1, this is the number of states. N number of items, because I was there in the first parameter. Weight can at most be W, so W. K is this. Okay. 1 plus number of transitions. How many number of transitions are we doing for one particular state? For this, how much are we doing? How many transitions? Quickly, give me in the chat. Yeah, all the numbers. So that's why we are multiplying, no? All the numbers for all the n's for all the k's. So we are multiplying. 2. So this will be nothing but order n into k into w. Okay, this is constant. Order notation, it just suppresses constants. So this is my complexity. If this will pass, we will code it. If not, then we'll not code it. Okay, that means we have to optimize something further. But this will pass, assuming that for this code, it is given in the problem ki n, k, w is up to, let's suppose, 100. So if you put 100 in this, 100 into 100 into 100 is 10 to the power 6. We know that in 1 second, 10 to the power 8 will pass. If you put formulas into that, that should be good enough. But w can only take discrete values. But whatever discrete values it is, it will be in the range 0 to w only, no? So that is fine. +1, because what if you don't have any transitions? So I'll give you in one single sentence. This is nothing but this formula that is written is nothing but v plus e. Number of states is number of vertices. Vs into average number of transitions is total number of transitions. That's edges. We are actually doing DAG पे DFS, but I'll not explain that any further. Just for people who are super interested. ग्राफ नहीं पता तो नहीं समझ पाओगे, इसलिए मैं बता नहीं रहा हूँ. I'm not explaining it. Okay. Okay, this is what we are doing. How do we find average number of transitions? In this case, 2. Just take average across all states. यहाँ पर 2 दिख रहा है ना, 2 arrow. This 2 arrow. That's 2. 1 means states will also have a cost. Building those states, initializing them with 0 will have a cost. ये समझ लो. Okay. So let's say this much is good enough. Take not take other 2 transitions or 2 transitions. How many of you are now 70% clear till this step? What did we do? We thought of the form कि ये take not take वाला format है, subset. Based on that, we took a idea कि I'll be at the ith item and decide whether to take it or not. Based on restrictions, I put certain things on my parameters, and return value will be the same thing asked, but only for a sub part of the problem. Yes, there are 2 to the power n calls, but we'll come to the code. How does it make it faster? Okay. Then in designing, based on the setup, because once you do the setup 1 and setup 2, this step becomes super clear, right? That once you design this setup, it's obviously 2 choices. So for the 2 choice, write the configuration where you are going. That's natural. Once that is done, you do a simple check quickly कि भाई pass करेगा नहीं करेगा. Then you code. Next, I'll teach you the framework to code DP solutions for all problems. Does this make sense to all of you? कि यहाँ तक समझ में आ गया? That how to design solutions for this. Next, I'll show you how to design codes for like problems like this. Now, this is in fact done. If you can think for every problem will have the same steps. If you can think it this way, you will be able to get to the final step, and then you will be done. Okay. How do you decide whether to take it or not take it? That code will decide. Will not decide. तुम लोग खाते खाते करो dinner time. Keep eating. You don't need to wait for me. खाते खाते देखो भाई ये कौन सी है ना. चलो जी. Let's average number of transitions means number of possibilities for every I. Over here we had two number of lines that you have over here. Okay. If it gives TLE, then maybe we should look for optimizations. Yes. Yeah, I'll give you homework questions. Don't worry. इसके बाद तो तुम लोग lead code पे आंख लगाओगे. Don't worry. I'll give you try all the traditional interview questions after this, like coin change. I'll give those as homework. Knapsack. सब बना दोगे. Same चीज. Okay. No, I don't want to go fast. I know that you guys, some of you might know, but for many this should be good learning. So I think this pace is good enough. इससे ज़्यादा स्पीड जाऊंगा तो people will miss. Next code करें थोड़ा बहुत. Let's try to write some pieces of code and understand. Just write number only. Don't write average for now. But it's, if I have to take truly the word, it should be average, because you will later on realize there are problems where the number of transitions each state is not same. It's not take not take for everything. It might be dependent on the number of divisors of certain thing, and you need to take average number of divisors, things like that. I just don't want to be wrong. Okay, let's move to the coding now. So I'll use very simple online GDB, because I know all of you might not have done setup, or I don't know if you have a setup or not. So I'll use online GDB so that you can replicate whatever I'm doing. Just go to onlinegdb.com. Don't run it now, okay? Maybe the site will become slow. Okay, so I'll just quickly set up basic things. I hope if you are attending the DP class, then you know what this headers means, using namespace, std, right? Just basic stuff. Right? So classical, so this is not, I don't think 90% people who know already this problem can also code it correctly. I don't think so, because I've added this simple state, and I can design 5 number of states that if you take the first item, you cannot take the last item. Just add another restriction, add another state, and I can keep putting in add. जो मेरे को 3D 2D DP बोलते हो वो सब कुछ फायदा नहीं है. Okay, no help, no need for that. वो सब कुछ नहीं होता. 3D 2D 9D बना दूंगा मैं अभी. I'll add just 2 more restriction and it will become 5D. There's no D's and stuff. Okay, this is what we'll do. So do you have a setup? I'll zoom. Clearly visible to all of you? Need 1080p. I think it can be upgraded for free, I think. Folks who are managing can check. For first week, you can upgrade on StreamYard. Okay, so the way we will take the input is, you are given n, the total number of items that you can take, and the number of this you can take, right? The k and k restrictions, the total maximum weight you can take, and number of items you can take. One, मतलब function में कितने parameters है उसको लोग बोलते हैं states बोलते हैं, right? So that's what it's called. So you will take n, w, k. Now you have bunch of weights given to you, assuming there are only 100. So I'll take weights of profits of the items. So ith item. So let's suppose you are given for integer I equal to 0, I is less than n, I plus plus. All the items has the given profit and the given p of I and p of, let's move this, it's difficult to type, w of I. Okay, so the profit of the ith item and the weight of the ith item. Okay, so this is what we are taking as an input. Next, what will we do? A quick step. Too much rain. Give me just 1 sec, guys. I'll quickly fix one thing. Yeah, you can define anywhere, wherever you want. ये तो गायब हो गया. कितना भी d बना देंगे भाई, कोई दिक्कत नहीं है. चलो जी, let's continue. So we took the profits, took the weights, and we want to design the DP. Okay, I just took it global because you can also pass it in function, but I'm lazy. Okay. Okay, let's move into designing the solution. So we will write integer recurrence, which will return us given I, how much weight we have taken, the same things that I wrote over there. Right? If I'm at the ith item, I have taken this much weight, I have taken this much k. What is the maximum profit I can do? This is what I should write. Okay. Next, I'll write three things: pruning, base case, recursion, transition, recursion, return. Okay, this is how you write recurrences. This is how you write recurrences. There is no pruning in this problem as such needed, but if wait, we don't need any pruning. Okay, in this case. So we were deciding for a 0th item. Usko decide kar liya, we go to the next item 1, we go to next item, and so on. What will be our base case? When we are deciding the last item, we are done with that, and we will move to the next item. So we will go to state n when we are reaching this. Pruning means if something is trivially not feasible, then you can remove them. Like maybe if w taken is greater than w and stuff, you can write that, but we will never reach there. I'll explain that when we write it. Okay. Pruning means something that is not feasible, you can remove them off in that DP piece of code. So over here, when you are at a particular item, if you decide it, you go to the next item. When you decide this, you go to the next item. So when you are deciding the last item, n minus 1th item, 0, 1 till up till n minus 1, you will reach till nth item. Nth पे तो कोई item ही नहीं है. There is nothing to decide. So what can we write? Let me give it over here. I'll move this up, right? This would be better. If I is equal to n, that means we have decided all the previous items. In that case, how much profit can we make from the rest of the item? Return 0. Perfect. It should be return 0. Why? Because for the rest of the item, there is no profit to be made anymore, isn't it? समझ में आ रहा है? If I have reached the last item, the definition of this recurrence says if you are n to n, तो कोई item ही नहीं बचा है. So maximum sum of profit that you can make from it is 0. Is this part clear? First of all, is this base case making sense to all of you? Quick +1. We'll do step by step. Okay. No, this is top down. This is not bottom. Last index. So the array index is from 0 to n minus 1. So when we reach n, मतलब पीछे सब process हो गया. We are at last index. Next, we'll design recursion. That integer best, let's suppose, is equal to 0. One possibility is either I will not take it. If I don't take it, I will go to I plus 1. Nothing will change. Okay. But if I take it, if I can take it, there is a feasibility check over here also. कि भाई ले तो सकते, पहले check तो कर लो. Taken के लिए there has to be some conditions. There has to be some check. कि भाई ले भी सकते, can I take it even, or even can I take it? So if W taken plus the W of the current item is less than equal to capital W, and K taken plus 1 is less than equal to capital K, then can I say I can take it? Is this making sense? There is so the items are 0 to n minus 1. So at n there is no item. It's 0 indexed. N पे कोई item नहीं है. 0, 1 till up till n minus 1. So this definition I should update to n minus 1. Okay. Clear till this point? Quick +1. Great. Now, once I can take it, then one of my possible choices is, I'll just update it to answer. One of my possible choices is max of answer. Like if I don't take it, whatever is my choice, max it with, if I take it, for this item, I will get P of I, plus for the rest of the item, I'll go to this configuration. Same thing that I've written over here. Copy paste the same thing. I plus 1, W of I, k taken plus 1. कितने लोग को यहाँ तक समझ में आ गया? How many of you are clear up till this? Exactly the same thing we had written over here, just that if we can take it, then that is one of my possibilities. So take max across both the possibilities. This is always possible because नहीं लेना तो कुछ cost नहीं लग रहा है ना, it's free, so I can always not take it. But if I can take it, then I should try and take a max with that. So this is essentially what we'll do. So recursion will give me the best possible I can get without taking it, and with taking it plus getting the profit of this item. Take the best out of the two. Whichever is the best, return answer. Okay, easy. And this is something that you can call, if I see out what is the answer. Answer is equal to recursion of 0. I start from the 0th item. I have not taken anything. I have not taken any number of items. Whatever is the best, go and decide. Karke le aao. That will be my answer. This is how you do it every single time. Okay. Acha, what is the time complexity of this code? No, it might not always be possible. No, it will always try to take this, but it might not be possible if you take too many previously. What is the time complexity of this code? देखते हैं. How many of you have understood it? बताओ भाई, जल्दी बताओ. This is 2 to the power n. This is 2 to the power n. Okay, this is not DP. This is brute force. This is recursion. Vivek, आपने तो हमारे साथ धोखा कर दिया. No, this is not that. This is just recursion only. This is normal recursion, that for every item you are going on both the sides and you are like just trying everything out, and this is recursion. Okay, pure recursion. It's not a DP. But when you want to make it a DP, you just change this integer DP, that there are 100 items. It can take till weight, let's say 1000, and the number of items you can take is this. You add this DP array. You say that by default, I don't know any answer. I don't know any answer. So everything has -1 in the global array. So I made a big array. Okay. And everything has -1. This is a function that sets everything to -1. Okay. And then when I call certain thing, I check if there is a base, like cache check, that happens. If dp of I, w taken and k taken has already been, is not equal to -1, means I have already calculated it, then return that value. Okay. And if it is not calculated, then calculate before returning, save that value over here. Save this value over here and then return. So that next time, if the same configuration is called, it will return it directly from the cache array. Okay. So what did we do? Now this is a little like confusing maybe. Listen to me very, very carefully. For every item, I am trying to decide whether to take it or not take it. Just that instead of just calculating and returning, which was nothing but the visualization that we had seen earlier, the Fibonacci wala visualization, where everything was getting recalculated, we said, hey, there will be a big global array which will have values saved. And you can go ahead and complete, like check the value whether it has been calculated before or not. And if it has been calculated, then return that value directly from the saved cache. And that, my friends, make it DP. And now the complexity is n into w into k. Yes, you are correct. If there is no default value, then you can make a Boolean array to save things. Memset, this is a function of C++ which makes arrays fill with values like zeros and -1s. But don't use it with 1. It will not work. If you don't know the reason, Google, it's a very good reason. Okay. because it works on how does memset works, and things like this is asked in HFTs, by the way. Why does memset works with -1 and 0 and not 1? Okay, so this is how you write solution for DP, and this is in fact full code of DP for this problem. Memset is a C++ function which makes array memset. So this should be DP, no? My mistake. Answer was declared later. Memset has parameter DP, correct? Memset takes the array, the value, and the size of the array. It fills that value with that thing. Right. Thanks for the point. Done with this. Understood how did we build the solution code? There is a pruning, which means if something is not feasible, you can write. If W taken is greater than something, if it's not feasible, then you can write it. But in this case, you don't need a pruning, right? But I'm writing it because some problems might need it. You have base case, which is if you reach the last item, you have got 0. If you have cache check, basically, if that value has already been calculated, which means it's not -1 anymore, because you can always do 0 profit, no? So it can never be -1. So you can just save it and return. Then you compute, if it is not saved, then you compute both the ways and calculate the best possible value, save it and then return. Cache कुछ नहीं है भाई, it's a 3D array जिसमें बस ये parameters pass करेंगे और कुछ नहीं. It's a 3D array. That's it. Why not loop? Because it's just more lines of code. When memset can do it faster than looping, then why not use it? Not getting why it should return the best possible answer, it's falling sort of greedy only. Because it's the best across whatever feasibility, whatever you can do from the rest. Max of the 2 options plus the information that whatever in future also you can do the best is what is returning. It's returning best, not just any greedily. Okay. What is pruning wala step? If something is not feasible, if this state is not feasible, then you prune it here so that you don't go into these phases of lines, right? This is now the time complexity of this piece of code becomes O of n into k into w. O of k into n into w. Run the code. Chalo, run the code karte hain. What is the input? 3 items, weight was 6, I remember. Number of items was 2. What was the first? But I'm taking profit and this. Let's swap these two. What was the first item ka weight? 1, I remember. 3, 5, 2, 2, 4. 2, 4. Let's see if this runs. Oh. Semicolon mistakes. Let's do that quickly. 7. How much do we get? 4 plus 3, 7. Screen share हट गई. Okay. Guys. Yeah. This is how you basically manage this. So I wrote, this is the input, N3 is this is there. This is how you manage this. Why is it taken -1 if it's already taken? Why is it taking -1 if it's already taken? -1 समझा नहीं मैं. Why is it not taken -1? Because you are, how many taken till now? You are taking one more. So this is recursive way of implementing it. Okay. And this is in fact pretty much good enough for almost all things. And the power of this is so big that if you actually try and design any more solutions, like I can give you, but the lead code pe hard problem kaise bante hai? I will just, so this, if you have seen knapsack before, you would not see this line. I just added one constraint. I can add n number of constraints. If you take the first item, you cannot take the last item. If you take the first item, you cannot take the last item. If I add a constraint like this, कैसे होगा? कैसे करोगे? Simply add one more state. Simply add one more state. Ki have I taken the first item? Yes or not? Based on that, you can maintain ki can I take the last item? Yeah or not? Okay. If I'll tell you ki you can only take items such that their weights sum is divisible by something, or I can tell ki kuch to bhi restriction mein add kar दूंगा. So all of them will be the same thing. Okay. तो बस यही steps बार बार follow करने. You have to design the same steps again and again, which is so इसलिए बोल रहा हूँ DP का D is nothing. It's just dimensions जो होते हैं just gets decided by the number of restrictions. I can add n number of restrictions. मैं तुमको 9D 10D DP ऐसे दिखा सकता हूँ. That doesn't really matter. Okay. So this is something that you guys can now go forward and build on top of it. Okay. Now, which problems to solve after this? Have you heard of problems like coin change problem, knapsack problem? इसे सुना है कभी नाम? Maybe I'll send the links across for these ones. Okay, you guys can try these problems on LeetCode and stuff. You will be able to design solutions super easily now. Exact same process, every problem. सब में same है. ठीक है, edit distance is a different form. Okay, you will try this. Okay. If I becomes greater than n for any reason, will it return infinite, right? Yes. Okay. So now I think we have covered significant for today. Like this will help you solve both the problems that will be there as a quick home task. Knapsack and this, will send that across to you all. Try that problem next to design the solution for it from scratch and thinking about it. You can also think of unbounded styles. Like what if we have infinite supply? What if we have that every item can be taken multiple number of times? How to handle that? Maybe you'll have an idea like, hey, I am at this item. I can either not take it and go to the next item, or maybe I'll take it but stay at the same index. So if I just go back to my code and if I take it and I just remove this, this becomes infinite supply. Every item can be taken infinite number of times. Yes, so just change this and you now can take every item infinite number of times. Why? Because you are saying, I'll take this item, but I'll stay at I. That's how it works. Okay. Perfect. I think I have almost taught you the framework which people after 50, 100 problems still can't figure out. So you should now be able to build on top of this very, very quickly. Okay. Next is obviously like practicing a little bit. Like there will be more classes and you will be getting more ideas and stuff. But I hope you guys enjoyed today's session. I think this, like going beyond this might be too harsh on you guys for the first day. You'll be saying, Vivek, bahut padha diya aaj ek din mein. But then I hope you guys are, you guys like the content. Next class mein, like I think there will be more content covered around DP and you'll get more practice on things like this. Iterative and stuff also will be covered, right? All forms. So some of these forms I've covered on my YouTube channel. Like there was a DP workshop on which I've covered all the DP forms so that you guys can check out. Okay. You can parallelly keep learning for multiple sources, no? Right? Sure, it cleared every several doubts. Yes. Code काम नहीं किया. कहाँ किया ना? 7 आया ना output भाई, क्या बोल रहे हो? Run करो ना code. Output आएगा 7 हमारा. अच्छा, अब तो हमारे पास infinite supply है, so अब 8 आएगा. How it will come 8? I'll take this twice. There are 2 restrictions, 2 item restrictions. So I'll take this twice, so it will get 8. Even though the limit of weight has not hit, this will take infinite supply 2 times. So if I have to list all forms, like I'll just quickly give you a brief. Form 1 is this knapsack wala setup, which is items, every item, take, not take. Then there is form 2, which is LIS wala format, where you are building subsequences by jumping over things. Form 3 is nothing but multi-sequence. Matlab, there are two sequences and you are solving for parts of this edit distance, LCS, all of these are of this class. Form 4 will be nothing but interval DP or LRDP, where you are solving for an array for a part from L to R. Form 5, which I teach, is essentially game DP. Form 5 will be games. So you are at a configuration. You will go to a winning state or a losing state depending on how you play, right? That's there. So these are multiple forms, but I think you will learn these over with practice. Don't worry. We'll learn these with over practice. अभी form नहीं, अभी हमने आज form 1 सीखा. Try solving form 1 problems. You'll get those questions on the channel. Please mention channel. You can search Vivek Gupta competitive programming. That should give you. I'll show once. Okay. That. So I've taught DP once. Let me search for that. I'll send across that on Discord also. I think DP workshop should be fairly helpful. So you guys can watch this one, right? You can search for Vivek Gupta only. And this DP workshop you can watch once. Probably one same question from today one, but this one you guys can watch. This is like day 2, day 3. This is like for form 1. You guys can watch form 2, ending form, LRDP, game DP. These are all rest of the forms, and then building solutions on top of it. And solving at coder educational, solving CACS problems. Should be helpful. Okay. मतलब दम है एडवांस वाला तो पढ़ो भाई, कंटेंट नहीं है तो छोड़ दो. ठीक है, नेक्स्ट आई थिंक आई कैन टेक सम क्वेश्चंस. अब मैं और डीपी नहीं कर सकता. यस, फॉर दोज हु वांट डीपी वर्कशॉप का प्लेलिस्ट, इट्स ऑन द चैट. You can stick with iterative if you are able to understand everything, but I think for beginners, if they like, there are tons of things that you can design around on recursive solutions. It's much better. Like I've been teaching for a long time, but from my experience, I have been able to teach on recursive better because people are then able to design states very easily. Please explain optimal substructure. अरे optimal substructure क्या था? हमारे ने जो solution बनाया, I W taken K, इसका जो मैक्सिमम है वो इसके छोटे इंस्टेंस के I W taken +1 K +1 इन पे डिपेंड करता है. तो मैक्सिमम पे ही डिपेंड करता है. दैट्स कॉल्ड ऑप्टिमल सबस्ट्रक्चर. ऑप्टिमल वैल्यू अपने छोटे वाले ऑप्टिमल्स पे डिपेंड करता है. दैट्स कॉल्ड ऑप्टिमल सबस्ट्रक्चर. ओके. Can you give example of when this DP reaches the same state twice? Possibly two different items having same weights. फर्स्ट में नहीं लेके सेकंड में चला गया, सेकंड को ले लिया, फर्स्ट को लेके सेकंड को नहीं लिया. दे कैन बोथ रीच टू द सेम थिंग, राइट? नंबर ऑफ स्टेट्स, थिंक अबाउट दिस. नो रेस्ट्रिक्शंस के ऊपर थिंक अबाउट रेस्ट्रिक्शंस. व्हाट इज रेस्ट्रिक्टिंग यू एंड व्हाट टू पुट इन द स्टेट सो दैट यू कैन डिजाइन द ट्रांजिशंस. दैट्स हाउ यू डिजाइन स्टेट्स, राइट? व्हाट इज स्टेट? द पैरामीटर्स यू कीप इन द फंक्शन ऑफ डीपी is called states. Is there much performance difference between different DP approach like recursion? No, not much. For some problems, yes, might be because of the reason I told, the difference between top down and bottom up, but in general, no. So I'm learning some courses and doing this, so will it not be to self practice but giving context? कर सकते हो. I mean, it's up to you how much time you want to give. Can we do it? Can we give an object twice? Yes, you can loop over a particular item that I'm taking it k number of times. You can loop over k for integer number equal to 1, number is less than equal to some fixed value 5, number plus plus. You can take it number of times. So in this case, you can put, if you take it number of times, this much weight you are taking and this much number, so number. it will allow you to take this many number of times. और क्या? This is how you design. ऐसी क्लैरिटी रखो भाई, ऐसी क्लैरिटी में क्वेश्चन सॉल्व होता है, तब मजा आता है. ये नहीं कि भाई कुछ कुछ करके कोड पास करा दिए. Build clarity like you can solve any problem given to you. नहीं, time complexity difference not much. Some optimizations are possible only on iterative, but there are certain problems which recursive code will only pass because all states are not visited. So, but they are exceptions. So, technically no difference. Lead code or code forces, depending on your goal. If you want to get good at CP, then code forces. If you want to get good at intern placement, then lead code. Okay, so I hope you guys enjoyed this. Can I get 80 LPA placement? 80 LPA technically will only be feasible with very few startup-ish companies at the start, and like next you'll have to go through और गो टू HFTs. ठीक है, उसके लिए अलग रिस्ट्रिक्शंस है. SST में जाओ भाई. हाँ वही लाओ भाई, CG लाओ. मतलब मैंने देखा है बहुत लोग को जाते हुए. तो द थिंग इज CGPA चाहिए, डेव स्किल्स, CP स्किल्स उस लेवल पे चाहिए. लाओ, अगर वैसा है तो जा पाओगे. डिपार्टमेंट भी चाहिए. दैट्स ऑल्सो अ रिस्ट्रिक्शन, टू बी फेयरली ऑनेस्ट, है ना. I've been teaching for like 4 years now, right? I've seen so many students getting into HFTs and stuff. So these two things would be needed: CGPA and good CP skills. कॉलेज भी चाहिए. हाँ मतलब हाँ, true. I have talked with HRs of HFTs like for direct recruitment. So the only restrictions is you'll have to have either JE, top JE rank, or you have to be in top IITs with certain restrictions. ठीक है. Is your video on computer fundamental? No, that's not enough. That's good enough start. Then you'll have to go through the resources I've mentioned in the description. But it's good video. You should watch it first because I think most colleges miss on that one video. HFTs 1900 plus चाहिए होता है यार, मेरे को ऐसा लगता है. HFTs are high paying companies, high frequency trading companies. Okay, how much took time to do good in become God in CP? 3 years after 5,000 problems. Obviously, I'm sitting over here this because of this. Slides कब मिलेंगी कोर्सेज की? Slides क्या करोगे? वीडियो ऐड किया जो देख लो. If everyone has registered, yes, go to IICPC.com. There you can register for this. Quant like Chain Street, like Indian companies, Quad Eye, Alpha Grep, ठीक है, Graviton. These are the companies that you will be targeting for. There are many more. Like a lot of my students from IIT Delhi, Bombay, KGP. मतलब IIT चाहिए यार. I think that has become non-requirement. CP URL आपका. CP URL. If you want a URL, I can give you one URL which you can go through. Linktree. I'll give you my Linktree that is on the LinkedIn. If you want to reach out to me, it's better to go to LinkedIn because that's where I'm mostly active. Maybe you guys can share this. Also, there is a novice camp that will start from 4th of June. So if you are very new to this, make sure that you like attend that. Okay. करो भाई, add put a DP problem करो. I always recommend that. If you guys, Harsh PGs from, try करो भाई. How many units you can, but it's difficult. HFTs have many of HFTs in India, like from what I've talked to their HRs directly, is under 1,000 rank. That's sad reality. Okay, but some companies have good chances. I'll be very fairly honest. Yeah. Yes, that's true. Newbie at CF. Yes, कोई नहीं. Practice करो यार. I think you guys will improve. I'll take some more time. Few more questions maybe. I meant CS. Ask companies. I'm unable to solve fourth in lead code, and above C in display. Good amount of practice here. You will need to know all standard ideas of all topics. Then only you'll be able to go proceed to fourth problem in lead code. Right? नहीं नो मैं तो बस आज एक सेशन ले रहा हूँ यार. नेक्स्ट क्लासेस विल बी फ्रॉम डिफरेंट स्पीकर्स. आई जस्ट फ्री आई थॉट कि लेट्स टेक वन सेशन फॉर यू ऑल एंड आई होप यू गाइस एंजॉयड इट. But I think multiple speakers will take multiple sessions and they'll also designing it really well. So I hope you guys enjoy those sessions too. Quad I बिना interview के अंडर को लेकर. Yes, that's true. Because quant role मिल जाएगा. Systems वाले के लिए you'll take interviews. You'll take interviews on core C++ वाला. Ops पूछेंगे अच्छे से. Prepare कर लो अच्छे से. Code check और code forces this rating loss होने के fear को कैसे counter करें. रेटिंग लॉस होने का फियर कैसे काउंटर करें. दो आइडिया है. देखो एक अच्छा एक खराब. एक अच्छा टेक्निक क्या है कि यार थोड़ा समझो कि रेटिंग अगर मैं आज आई कैन मेक अकाउंट एंड आई कैन गेट रेटिंग इन 4-5 कॉन्टेस्ट इफ आई वांट 2100. सो इफ यू रियली गेट टू अ लेवल यू कैन गेट रेटिंग एनी डे. दूसरा तरीका खराब तरीका अगर तुम्हें सच में इतना नर्वसनेस हो रहा है व्हिच आई हैव समटाइम्स सजेस्टेड टू सम पीपल, क्रिएट अनदर अकाउंट. ठीक है, जिसमें कम रेटिंग है उससे पार्टिसिपेट करो. हमेशा कम वाला रेटिंग ही चेंज होगा. बट आई वुड नॉट एडवाइज इट ऑब्वियसली. Okay. Small roadmap, tell about topics from newbie to pupil. Mostly you'll have to improve on greedy, constructive implementation a lot. That's something you should improve on a lot on. Okay? Is bringing code videos bad because actually first trying to solve each problem. The more you see codes, the lesser you grow. That's my philosophy. I have taught so many students as of now. Maybe you will believe me now or maybe you'll believe with experience. But the more videos you see in which the solution code has been shown and then you go and solve this problem, which is practically the problem with every sheet in this world, the lesser you grow. This is my philosophy from teaching so many students. I've tried and tested it multiple times. It works. The lesser the codes you see, the more code you try to write on your own, the more you grow. So see less codes. You can see hints, you can see editorial English, but don't see codes. Just follow this philosophy, you will grow 2x faster than most other people on average. Because मेरे पास हजारों लोग आते हैं जो बोलते हैं विवेक मैंने शीट देख के पूरा सॉल्व कर लिया बट मैं ग्रो नहीं किया. क्यों नहीं ग्रो किया? क्योंकि मैंने वीडियो में सारे कोड्स देख लिए फिर वही टाइप कर दिया ऐसे करके. और अभी भी मेरे से नए क्वेश्चन कोड नहीं होते. Learn from editorials. हाँ yes. सेम के लिए टिप्स करो भाई, अच्छे से प्रैक्टिस करो. ग्राफ डीपी स्ट्रॉन्ग कर लो यार बहुत ज्यादा. बी सुपर स्ट्रॉन्ग एट ग्राफ एंड डीपी. आर यू फ्रेंड्स विद स्ट्राइवर? नहीं यार, आई हैवंट मेट हिम. डू रिविजन required to be good at solving. How do you revise? I generally maintain a sheet of problems that I have solved earlier and then go through them mostly. But whatever I have solved this. Why is there so much crowd on this small channel? Because they are doing a really good job by helping people to get into CP. That's why there is so much crowd and there are people who are interested. CF, div 2, div 3, 4 तक कितना टॉपिक्स enough है. DP ग्राफ तक पहुंचना पड़ेगा, but थर्ड तक पहुंच like 1400 पहुंचने के लिए I think you can do without DP and graph, but after that you'll have to learn. Specialist to expert, I think deciding factor becomes DP and graph. मतलब उसके बाद तो कभी-कभी constructive होगा, कभी नहीं होगा, but you have to get really good at DP, graph and also maths obviously. Code forces में तो यार maths is like inevitable. How often need to revise things? It depends person to person, but I think whenever you find next instance where you forgot something, revise then. When CF rating is good enough to clear most OAs, 1600 plus should be good help. 1900 plus you will be able to almost crack almost all OAs. Maybe 1-2 left, except HFTs, 1-2 companies. Some companies are still harder for 1900s, but in most companies, yes, you can do that. This is for tree and graphs. I don't have any resource at this point in time. Google. How to improve maths using CP. Read more proofs. I think that's how you'll improve. Bit manipulation. Taught one technique today on my channel. देख लो वो video देख लो. आज का lead code का 4th problem देख लो जो मैंने discuss किया आज. You'll understand what you need in bit manipulation. Have you designed any problem sheets? No, not yet. I think not big fan. bit manipulation, bit DP. I mean, JEE का combinatorics is really good. Number 3 you'll have to learn a little bit. JEE का maths तो यार चाहिए, combinatorics चाहिए, PNC चाहिए सिर्फ. Big fan sir. Nice, चलो. Comfortable in lead code problems, not able to perform at lead code forces because of ad hoc and maths, most probably. Will digit DP be taken in these sessions? Yeah, most probably. These guys will arrange that. I think they have planned fairly well, so there will be sessions on everything. Okay, this will be my session from my side. Next session, say, or be more instructors will be there. They'll teach you really well. But I hope you guys enjoy the camp, and I hope you guys grow. Let's, I think, keep it up till this. Few more questions. Lest, I think, on YouTube I have covered a lot of things that I generally talk about. तो सारे चीजें जो questions तो मुझे पूछ रहे हो सब मेरे YouTube पे covered ही है. विवेक डेव सीपी कौन सा कैसे मैनेज करे, कौन सा प्रोडक्ट बिल्ड करे, कौन सा प्रोजेक्ट बिल्ड करे, सब चीजें मैंने बता रखी है. सो हैव अ लुक एट दैट. डीपी, या डिजिट डीपी इज कवर्ड इन एनी ऑफ. सो डिजिट डीपी इज एडवांस फॉर्म्स, डिजिट डीपी, ट्री डीपी, बिटमास डीपी, these 3 forms. Bitmass DP, if you want, I can share you a link. Bitmass DP के लिए I'll get you guys, like there is this course that I had built earlier which you can watch through. 6 application, everything covered. You don't need anything more than that. भैया गूगल में कितनी रेटिंग के क्वेश्चन आते हैं? 1600. मैंने गूगल में इंटरव्यूज लिए, 1600 लोग टाइप के लोग क्लियर कर लेते हैं इंटरव्यूज वगैरह. बाकी तो मतलब उससे कम में मुझे लगता है थोड़ा फ्लेकी दिखता है मुझे. बट 1600 प्लस वाले लोग जब मैं इंटरव्यू लेता हूँ तो मुझे समझ में आता है कि यार ये बंदा सोच के बता पा रहा है. So I felt that. How much do you earn per month? Probably more than what you think. Struggling in iterative DP directly. Struggling in writing iterative DP directly. Don't try. Or learn how to convert this structure into iterative. I have covered that on my DP workshop. इसको कैसे convert करते हैं iterative में? How do you design any problem sheet? I have not designed any problem sheet. Please consolidate all the links and share it in this. Yes, good. Thanks, bro. When will you marry? भाई अभी मैं बहुत young हूँ भाई. I'm going to turn 26. 25 का ही हूँ मैं भाई. इतनी जल्दी मुझे जिंदगी बर्बाद नहीं करनी. Okay. खुश हूँ मैं भाई बहुत. Please share Bitmass DP resource. Yeah, I'll share it in the Discord later on. ठीक है. It's on the mang.nk website. You can see it on the free course. Conditional versus iterative, which one is better? Top down, I think is better to start. Yes. It's okay to use ChatGPT for a code snippet during contest. Yes, it's fine. If you can use it, probably. Okay जी, चलो फिर. I think this is a good place to wrap it up. 10:30. काफी देर हमने डिस्कस कर लिया. But I hope you guys enjoyed learning the fundamentals of DP, recursion to transition to those steps of formulation, the framework जो हमने सीखा, and coding के भी implementation style. Obviously, the more you practice, the more better you're gonna become. Watch the DP workshop. Watch the next classes that will happen on the camp. You guys will be able to grow very, very fast. Okay. So best of luck for the camp. Keep learning, and I hope you guys grow a lot. On my LinkedIn, you can send me a quick connection request. I'll accept if you just mention कि I was in this live session. Okay, this is for anybody who's watching it. If you mention that, I'll accept it. या नहीं किया तो Instagram पे भेज देना यार मैसेज. ठीक है, उस लिंक ट्री पे सब है, भेज देना मेरे को. I'll accept it. Okay. Mention कि I was in the live class क्योंकि 7000 pending messages है. I cannot possibly accept more. Here is. ठीक है. Cool. Chalo then. Thanks for joining in, guys. We'll meet up in the next class again. See you all in the next one. Bye-bye.